problem. Okay, temporary rivet problem. Okay, so a machine frame is subjected to a load of 10 kilonewton. So 10 kilonewton load from at 500 eccentricity is 500 mm. Eccentrically, the distance between each rivet are 200 mm as shown. This is the distance 200 mm as shown in the figure. Take maximum shear stress is not exceed 75 Newton per millimeter square. Determine the dia of the rivet. Okay, so this is the diagram. There are four rivets. Okay, the distance is 200 from center. Okay, so what is the data given? Load 10 kilonewton, eccentricity is 500 mm, E P. Okay, number of rivets n is equal to 4. Maximum shear stress வந்து 75 Newton per millimeter square. Okay, so you can redraw the configuration. Okay, it is from center. The rivet number one is likely to uh, stress more than other rivets. Okay, so you can consider the rivet one. So it is from center. It is 100 mm and next direction, 100 mm in y direction. So what is a? It is a right angle triangle. So the angle is 45 degree. The distance r1, the radial distance is 141. Okay, according to Pythagoras theorem. Okay, so like, with that you can solve the problem. Okay, first we have to find out the primary shear stress. Okay, primary shear stress. Okay, F1 is equal to, so what is the load? 10 kilonewton. Okay, so 10,000 Newton divided by 4. It is equally shared by 4 rivets. So what is that? 2500 Newton primary shear load. Then you have to find out secondary shear load. Okay, shear load. Okay, F2. Okay, so what is F2? F2 is equal to, you have to find F2. You have to choose the formula P into E, that is equal to F2 divided by um, R1. Okay, R1, that is equal to R1 square plus R2 square plus R3 square plus R4 square. Okay, so what is the load? 10 kilonewton, 10,000 Newton, that is 500. Okay, that is equal to F2, we don't know, so R1 we know the 141. Okay, so here all, since configuration is geometry, so all the radial distance will be 141 mm. Okay, so 141 square plus 141 square plus 141 square plus 141 square. Okay, so you can 5 into 10 to the power of 6. Okay, is equal to F2 divided by 141. Here 141 square into mm, 4. Okay, so you can yes, you can solve this way. You can strike out square. So what is F2? F2 will be 8839 Newton. Okay, so resultant load R is equal to root of F1 square plus F2 square plus 2 into F1 F2 cos theta. Okay, so what is F1? 2500 whole square plus 8839 square plus 2 into 2500 8839 into cos 45 degree. Okay, so what is resultant? 10,722 Newton. Okay, so we know that resultant load is equal to area into stress, pi by 4 d square into allowable stress. Okay, so if you put the allowable stress value 75, so what is d square? D square will be 182.62. Okay, then d will be 13.5 mm, approximately 14 mm. Okay, so this is the result. So if you like the button, if you like the video, press like button, raise your command in the command box. Thank you.